it doesn't. What would that symbol become? No. It's more complicated than that. I don't know if you guys remember what this was. Yeah. To find the negation of something, you figure out how would you disprove this. Well, that's related to when would I be a liar, is if not P, but, if P, but not Q, right? If you do what you're supposed to do, but I don't. So the negation of this is equivalent to P, but, or and, not Q. Does that look like distribution at all? So we're not lucky there. But we got lucky here. What would that be?
Not P and not Q.
So there's no nice way to remember this, except you got to kind of tease it out. What's the opposite of this? When would this be a liar if the first part's good and the second part's not good? Right? You got to kind of do that. This, we're lucky. There's an easy way to remember it. It's sort of like distributive property. It is not distributive property, but it's like what it would be, right? Because it's sort of like I'm going to put that there. What's or become? Yeah, so I changed that. Not Q. So the Morgan's laws is just a compilation of the two things that look like distributive property. So, cool. Yeah.
So we're allowed to do that last part.
Totally.
Okay,
yeah.
So on the quiz, when you asked us a question similar to that, I didn't mess up.
No, on the quiz you could distribute the negative, but
okay.
you didn't have to.
Okay.
There was no need to do that. So if I told you P was true and Q is false, you would just do this. True or false is false is only false, or is only false from the both. So this is true, and then what's not true? There you go. So you can attack it like that. No need to apply to Morgan's laws, because this quiz wasn't on that section anyway. But if you knew it and you applied it correctly, I'm cool with that too. Yeah.
And if there's two negations, so that, like if there's one right in front of the P, would that cancel it out?
Oh, good. I'm glad you asked it, because I was going to follow this up with exactly. Because now that's logic. Yeah. Two negatives make a positive, even in logic. So if I had like not P and Q, what would that be equivalent to? P or not Q. So the way to remember it is it's a lot like distributive property. It isn't distributive property. But it looks like it, so it's easy to remember.
So kind of clarify, it's like distribution in the sense that it changes the stuff on the inside, but it's unlike distribution to where it changes the entire phrase.
Yeah, even the like symbol.
Not each part by itself, the entire phrase.
Yes, cool, I like it. So not only the players, but also the symbol in the middle. Yeah. But even that's sort of like, so if I had negative 4 minus 7, now here's where it gets a little bit strange. And that would be 4 plus 7, so it's still not quite, you're not changing this and this, right? So there's like an extra change, but it still looks a lot like distributive property, what I would guess it would look like here, right? It looks a lot like it, so it's easier to remember.
So if you were doing a truth table for that,
you could either do it the way it is.
Parentheses first and then apply the not afterwards. It's still the same answer.
The truth table for this and the truth table for this, what must be true? The truth table for this and the truth table for this. They have to be the same, right? Because these are equivalent statements. So of course, that's the whole point of why there's this definite order that you got to do the truth table in, so I can compare and see if they're equivalent statements. Yeah.
Okay, I don't understand how you got the if then and then at the top. You know what I mean?
Yeah, this one we had to tease out. We're not lucky like we were here.
Right.
I still kind of did this English-wise, right?
Yeah.
If it's not true that you or you did it, then you both didn't do it, right?
Yeah.
So English-wise that makes sense, but it also looks like distribution. Now here, again, it's false that this. What's the one time that this guy would be false if P and not Q? If the P is good, but the not and the Q is not good, right? That's another way just to remember that. But does that look like distribution? No.
No, not at all.
So we didn't get lucky there.
Okay, so if P, if and only then Q, if it's not true, then the negative, so if I did what I was supposed to do, and you didn't give me the car, then okay.
Yeah, so you did what you're supposed to do, but I didn't do what I was supposed to do, right? And again, that's sort of a way to remember it still, but still, that's sort of how the negative works with the if then. So the negative works with the different symbols in different ways. These two symbols, though, they're nice because it looks like distribution. Okay.
There's a problem kind of similar to that on the homework, number 7.
Number 7, yeah.
And that's the one I'm having trouble with.
I love number 7. So number 7 is the one.
Same thing too.
Wait, is it the same one I was thinking about?
147. 147.
Yeah, if P implies Q is equivalent to not P or Q.
Wait, what?
Just number 7, 3, 4? Or 3, which one?
3, 4, yeah.
3, 4. Number 7. So if P is equivalent to this, right?
Okay,
They start off with that.
Okay.
Write a conjunction that is equivalent to not this. And again, these two are equivalent because if you get an A, then I'll buy you a car. So either you don't get an A, or I buy you a car. That's what's going to happen, right?
Right.
That's why these are equivalent, because it makes sense in English too. So logic's always got that backup of English you can use if you need to. This is going to kind of prove this too.
So this would be.
So how would you do it? If this is equivalent to that, how do you check what this is equivalent to? Don't you just put a negative?
Not P and not Q.
You just put a negative in front of that, right? If you do negate this side, you better negate that side. Do the same thing to both sides, just like in algebra,
Well, why
right?
would it be not P?
Hmm?
Why would it be not P?
It isn't not P yet. So what did I do to this side?
On the one.
No. What did I do to this side? Did I put a negative on the outside? Right? Isn't that what they're asking about? So what do I have to do to this side? Put a negative on the outside, right?
So are we looking at both those symbols as an equal sign, the 2 arrows?
Yes, it's just like equals in, that's why I call that like a super equals. It's just like equals from algebra, right? So again, the problem gives you this, don't they?
Mm-hmm.
And then they say, what the hell is that? Right? Right?
Right.
So they say, okay, this is true. Yeah. What the hell is this then? Right?
It's not. Doesn't make sense.
No. That much should make sense because that's all they're asking. So they say, this is true. Okay, we're good there. They say, that's true, we're good there. Then they ask you, what the hell is this? Okay, that much you have to agree with because that's just the question.
Right.
How do you use what you know to get this then? What's the only difference here? What do they do to this? They just put a negative on the outside. But what do you know this is the same as?
But they only did it to the P. That's what I'm confused about. When you.
No. Okay, no.
Well, when you.
All right, wait.
So when you did the equal
Are
sign.
you looking at this? Or what are you looking at?
When you brought it down.
Yeah.
You put. It was not P and there was a not on the outside of the parentheses.
Of course. Because what did we do to this side?
But then the 2 negations would cancel.
Beautiful. You keep going. Now you simplify it, right? That's the next
But
step.
it wouldn't factor out on the first one. Like, do the equivalent what you had before with
Yeah, so they put a negative on this side.
on that one.
So I have to put a negative on this side, right?
Right, on that side, the 2 negations, if you were to distribute it, the 2 negations would cancel each other out, but they wouldn't on the other side.
What other side? What are you talking about?
On
Not
the
P.
first one.
I don't care about this.
Yes.
But they have to be
That
equal,
was the
don't they?
question.
Of course they have to be equal. All right. So this is equal to this, right?
Okay.
Now that's a not P. Is that a not P?
Right?
No, but we know that these are equivalent. Period, right?
Right.
Okay. I know that this is equivalent to this. I want to use that fact to figure out what this is equivalent to. Now, do we know what happens when I distribute? And again, distributive property doesn't work, but do I know what happens when I bring a negative inside here? No, but thank God I know another way to write an if-then. I can write it like this. That's what they told us. This is equivalent to that. So do you want to work with this side and bring the negative in, and I don't have a clue what the hell it does, or do you want to work on this side where I know what the hell it does? Yeah, I want to work on that side. So now you can figure out what that equals this, which equals, what does this equal?
P.
Not P is?
P.
P
And
and,
not Q.
which is another way to prove what we got up there, right? It's a little more mathematical way to prove. Up here we prove this English-wise. There's a mathematical proof of this. No, again, I don't want you to feel like I'm angry at you. I just,
No,
I feel that I sometimes come off that way, but
it's just something I gotta stare at for a little while before I
it's
get
just
it.
me trying to work through, and again, everybody, the way I communicate with you is going to be different because I think differently, but I'm trying to see where it is I'm losing you, and that's what, you know,
That's
sometimes
number
it's
seven.
It's
frustrating.
something that I have to work through
Yeah.
myself before I
Okay.
get it.
But is that decent? I mean,
Yeah.
okay.
Okay, so on the truth table, can I ask a question?
Sure?
Okay, so, you know the last part of the truth table where you have to write out the equation and then you're solving for true or false, true or false. So when there's like or 2 or 3, and you know how you write like different columns, I don't understand why we're solving for, like even if there's just 2 different.
So you don't understand where like these come from?
Like, okay, so draw the truth table, yeah, and then the other side too, like that.
What do you mean?
Like draw another line and write the equation.
All right, well, that's what they have to tell me.
See, that's
Here's
the
a
part
truth table. I know that truth table exists, right? Then they have to tell me what the function is. So can't you start making an XY table? You can start making it, sure. -2, -1, 0, 1, 2. You can put whatever the hell. Do you know what to put here yet? Because they haven't told me a function yet. If they tell me that y is 2x minus 1, okay, you can start plugging stuff in. So they have to tell me what the function is. So the problem is going to say, okay, now do like not p or not q or whatever, right? Now you can start to attack it, right?
Okay, so like sort of, like the thing is, where, like how do you solve them separately? Because don't you draw 2 different? Like,
So you're always comparing 2 things. And the only thing going on in there is the or, right? What
so
am
we're
I?
not even paying attention to the PQ.
Well, these are my inputs. So the first thing I've got to do is sort of like, so if I had, for example, y equals 2x over 5 minus x squared divided by 3, you know, I can make that function whatever I want to, and you start plugging x's in. You first figure out what you want to plug in, okay, just like we did there. And then you start thinking, okay, when I'm plugging them in, I got to worry about order operations. What am I going to do first? What am I going to do second? Right? That's what you got to do. Order operations is always there. Same thing here. Here's all my possible inputs. That's the one little difference here. What could x be here? Infinite number of stuff. It could be 1.876. The nice thing here is p and q, they can only be true or false. So there's only this many inputs, right? Covers all the possibilities. Now you start to see what's this. I only got one operation, cool. But what am I oring to make a verb out of that?
No.
I'm oring not p and not q. Do I know what not p and not q are?
Yes.
I do. I have to write them down for myself, right? What's not p?
False.
Yeah. False, false, true, true. Because p is true, true, false, false. So not p here would be false. Not p here would be false, and so forth.
Yeah, okay, yeah.
And then not q, of course, would be like that.
False, true, false.
Okay. So then we just do like.
Now you
put it in the
or
center and
those
compare those
one
two.
at a time.
Okay.
Mhm.
Yeah.
So this row, I'm going to figure out what those inputs lead me to. False or false is false. And of course, the rest of them are going to be, because that's the one time it's false. Bam. And make sure I know where the answer is. Cool. Now, I understand that this is very foreign. Don't get me wrong. This is really weird if you've never seen anything like it. But I want you to realize you've seen stuff like this. It's just that we're not used to these operations, but now we are. That's what those 4 statements are. So you could have 4 statements like, when I add something, it gets bigger. When I subtract something, it gets smaller. You can actually make statements for the operations in math. So we have the operations in logic. They have their own way of working. Or works a certain way. It's only false when both are false, so forth. So it's just like defining what a division is, right? I'm trying to define what that symbol is, and then I can attack each thing one at a time. Okay. Do you want to do another example truth table, or what do you want to do? Let's see what we got. Okay. Let's do a 3-letter one.